but I'm just going to color it for you here. Okay, so what I have is a right triangle kind of in the middle of this picture, and I'm going to just outline that real quick. Here's my little right triangle here. Okay, now what this theorem is going to say is if you have a right triangle and it says the altitude, or they also call that the height, you know, area of the base is area is 1/2 base times height when you do a triangle. So the height, it goes from C to D in that diagram there. The altitude, if we draw it from the right angle to the hypotenuse in that fashion, what it does is it's going to create 3 different triangles that are all similar to each other. So when I draw this height in, I've got the big like overall triangle, ABC. Then you're going to have like little bitty baby triangle, which you're just separating it from the picture there. And then this guy here, you have like a medium-sized triangle. And all 3 of them, I don't know why I just did that, whatever. All 3 of those are going to be similar to each other. So there's 3 triangles. When you drop that height from the right angle to the hypotenuse of the opposite side, creates a right angle. The other thing here, I'm just going to draw in the picture real quick. This, whenever you have a height, it intersects the opposite side at a right angle. In a lot of these diagrams, the other angle here in this diagram would be ABC. That would also be a right angle. 90 and 90 add up to 180. Those 2 just make a straight line. So a lot of the diagrams don't have that other right angle, but I do have that, and that would be in the little bitty triangle there. So all of these are similar to each other, all 3 of them. Okay, so then I found this lovely diagram. We're just going to practice this. Okay, now, these are not the greatest diagrams I have ever produced, but basically I did to the side 3 triangles, like a big, medium, and a small, so you guys could like separate these and try to work with setting up proportions when we work on these problems. So I'm just going to practice in this first example, redrawing this so it's separated. And I'm not trying to be tricky or anything, but it's maybe going to be oriented differently than it is in the original diagram, but I put them so they all kind of match up when I have all 3 of them laid out. So this might take a second to do. So if I have that big overall triangle, the 2 sides that form the right angle, those are called legs. And in this overall triangle, I'm going to try to relabel this. The short side goes from Q to P, and P is where the right angle is at. So if I'm going to relabel this, QP would be the short leg in that large triangle I just outlined with my purple highlighter. Okay, now the long leg, the other side of the right angle, just goes from P to R. So I'm going to put the R here. And then the hypotenuse is actually, we've already got it all labeled, but the hypotenuse is across from the right angle, and that's from Q to R in that diagram. Okay, now, little bitty baby triangle. When you have the height, or the altitude of that overall triangle, that's this line that's inside the diagram. Okay, that altitude is the long leg in the little bitty baby triangle, and the hypotenuse is always across from the right angle, which they don't have drawn in here. So I'm just going to put a little right angle in there. Now, if I'm doing the labels here, the long leg in that little bitty baby triangle goes from P to S, and S is where your right angle is at. Your short leg goes from S to Q. S is where the right angle is at, so the Q would go there. And then the hypotenuse of the little bitty yellow triangle that I got colored in there would be from Q to P, but I've already got it labeled. Okay, and then the medium-sized triangle is this guy here. I'm just going to kind of make them different colors so you can see them. Okay, now, with the altitude in the medium-sized triangle, that altitude from S to P, that is the short leg. So S to P, where S is the right angle in that medium triangle, so it would look like that. And then the long leg is from S to R, and then the hypotenuse there is from R to P. Sorry, that's shaking around a little bit. But that's all we're practicing right there, is just relabeling that. That is going to be the key to doing like every single one of these problems. And then all 3 of those triangles are similar to each other. So same shape, but different sizes, and all the sides will be in proportion. All the angles that are corresponding that would be in the diagram are going to be congruent. We don't have any angle measures or anything other than the right angle there. Okay, the other thing you're going to see in several of these problems today is something called a geometric mean. And you'll also see this again in Algebra 2. But basically what this says is you can have proportions where what they call the means are equal. So basically what that is trying to say to you, two of the cross products will be the same. So in my little example, it says for any two positive numbers a and b, geometric mean of a and b is the positive number x such that this proportion would be true. Here's the deal with this, and you'll see this in a bunch of problems today. If I would actually solve this proportion, cross multiply, I get x times x, which is x squared. Okay, the other side of that cross product would be, or the other cross product would be a times b. What would I do if I was trying to get x by itself to solve that? What would you have to do to both sides? Square root. Okay, so that's literally all a geometric mean is. It's the square root of the product of two numbers. So just in general, geometric mean is the square root of the two numbers they're going to give you multiplied together. That's it. Just multiply, take the square root. So all I have an example too is just a little example. You don't have to set up a proportion to do this. Just take the two numbers. If you're going to find a geometric mean, it just means we're going to multiply the two numbers together. So 3 times 12, and then we'll just take a square root. So I would multiply first. Go ahead and figure out what that is. So 3 times 12 is 36. What's the square root of 36? 6. Okay, so that one's nice. All right, now you might also run into what we're going to see in this next question where what's under my square root won't be a perfect square. So if I do, this is just geometric mean, you're going to multiply the two numbers, take the square root. So 2 times 10 would just give me 20 under the square root. And all I'm going to ask you to do is, if you can, put that in simplest radical form. How would you guys break up, because 20 is not a perfect square, how would you break up 20 to simplify that radical? We haven't done this in a minute. How do I simplify 20? Yeah, the tree thing. Okay, so what do you think of when you think of 20? Just tell me two things multiplied give you 20. Yeah. 2 and 10, perfect. Okay. And then you just keep going from there. So 10 is what, 5 times 2, right? I broke down the 20, I broke down the 10. If you have a pair, which I have a pair of 2s, that comes out in front. And anything that doesn't have a pair or a partner, that has to stay underneath. So simplest radical form there, that's 2 roots of 5. Just make yourself a little factor tree. Does anybody have any questions? Okay, you're going to see this on the very first problem I'm going to do here with these triangles. So geometric mean is going to come up, not in every single one of these problems, but in a lot of them. Okay, so I'm going to separate from this 3 right triangles. And again, my drawings here to the side are totally not to scale. It's literally just to give you a reference to kind of help you out here. Now, we got to go with what we have in the picture. So if you look at the picture there on that overall large triangle, really the only thing I have labeled is the 6 and 4, which I'm just going to write this real quick. All the way across there, I could just go ahead and add those two numbers together. That would be 10. That's the hypotenuse of that big triangle, and that's literally the only side that we have labeled in that big triangle. I don't have this short leg or the long leg. There's no label on either one of those, so that's all I could label there. Now, little baby triangle right here. When you do that, okay, so if you have the height drawn between the right angle and the hypotenuse of the overall thing. In this triangle here, this is the long leg. On the other side in the medium triangle, it is the short leg. And you don't have to write that out, but in the baby triangle, that X is going to be the long leg. The short leg you can see there is 4. And then the medium-sized triangle, this guy here, we'll just do some stripes. Now, in that triangle, the X is the short leg. The long leg here is going to be the 6. Okay. Now, All three of these triangles are similar. I just need two of them to set up a proportion. So obviously we don't want to use the big triangle here because I don't have enough information to help me out. But I do have corresponding sides here in the medium and the baby triangle, and corresponding sides have to be in proportion. So I would tell you here the x and the 4 correspond to each other, and then I would also tell you the 6 and the x correspond to each other. So there's different ways you can set up these proportions. As long as you have the same cross products as me, we're good. All right, I'm going to do x over 4 equals 6 over x. So I did this x over 4 equals 6 over x. If you set it up different than me, that's fine. As long as you're doing x times x and 4 times 6 as your cross products, we're good to go. Now, this is going to give us that geometric mean here because I'm going to do x times x to get x squared. 4 times 6 is 24, and then this results in us taking the square root. All right, now, here I'm going to come over here so I have a little more space to make my tree. Now, if I see 24, I immediately am like, okay, 4 and 6. You can break it down in different ways. I'm just thinking 4 and 6. Now, 4 would break down to 2 and 2. 6 would break down to 2 and 3. I do have a pair of 2's here, but if you guys notice, when I broke the 6 down, that did not result in anything that gave me another set of partners or a pair, if you will. So I'm going to have a 2 out in front. What would you have left underneath the radical there? The 6, yeah. Like if these don't have a pair, you just put them back together. So it's just multiplication with that. So this will be 2 roots of 6 here. Is anybody having a question so far? The key to doing all these problems is breaking these triangles apart and relabeling them. Okay, so I just try to do like a little bit with each. Yes, ma'am. So x times x gives you x squared. X plus x gives you 2x. Does that make sense? Yeah, that's a really good question. Excellent question. So adding 2x, multiplying to add the exponents. Very good question. Okay. Now, this one's a little tricky. So here's my overall larger triangle, right? Now, when you're looking at that, the short leg is what in that diagram? Can you guys tell? What would the short leg in that big triangle be? What letter or number? Perfect. Okay. What is your long leg in that big triangle? 20. All right. Now, this is very tricky. How would I write the hypotenuse for that big triangle? Hypotenuse has to be across from the right angle. How would you write the hypotenuse based on that picture there? It's kind of weird, right? So it's this whole, that's the hypotenuse. And I don't know what y is, right? If I did, if it was a number, we could add it to the 16, but I don't. So I'm literally just going to do y plus 16, since I don't know what y is, but if I had those two pieces, I would add them together to get the whole side. So that's why I'm going to put a little plus sign there. Okay, now, my little baby triangle is right here. And again, this is a diagram. They don't draw the other side of this right angle. So this is my height of the original big triangle. This would also be a right angle. Okay, now, if this helps anyway, maybe cover up the rest of the picture if that helps you. Okay, the short leg there is going to be y. The long leg in here is that height of the original triangle, which is 12. And the hypotenuse is always across from the right angle, so that would be x. Forgive, I didn't color this. Color that there. Okay, now, my medium-sized triangle. This will be nice for us. Here's my medium-sized triangle. All three of the sides are labeled there, if you can see that in the diagram. So in my medium-sized triangle, short leg is just the smallest number, which is 12. Long leg is the 16. Those two make the right angle. Hypotenuse is always across from the right angle, so for that medium-sized triangle, it would be 20. Okay, now, if you have a triangle that has all three of the sides, which we do here, the medium triangle, right? That gives you lots of options, and there are many different ways that you could solve this problem for X or Y. What's going on here is all three of these are similar to each other. So I'm just going to give you one option. Okay, let's say I used the big triangle and the medium triangle. Okay, big triangle, medium triangle. I'm going to say that X corresponds to the 12. And I'm just trying to set up a proportion. You don't want to use any new, I don't want to use a proportion that would involve Y, just X's, all right? So if I do that, I would maybe just put the 20 and the 16 together. I wouldn't use the Y plus 16 and 20 because that would get another variable, and we don't want that. So I would just match these guys up like I have here. So something like X over 12 equals 20 over 16. And again, if you set it up a little different than I did, as long as our cross products are the same, we're good. So I'm going to cross multiply here. So I'm going to get 16 times X. 12 times 20, going to give you 240. And all you got to do there is divide by 16. So there's no geometric mean here or anything like that. We're not taking a square root. I'm just doing 240 divided by 16. So some of these will be a little bit nicer than others. This is just 15. Okay, now my other variable I got to find there is Y, and I've got that in a couple different places in the diagram. I've got it here, Y plus 16, and I've got over here just a plain Y. And again, I would probably use the medium-sized triangle since I know all the sides in that one to set up my proportion here. And let me see. I would just do this 12 goes with this Y, and then I can just do the 16 and the 12. Sorry, I'm kind of garbaging the diagram up here, but I'm just using the baby triangle and the medium triangle. I'm going to try to find Y here. So the 12 in the medium triangle corresponds to the Y in the baby triangle. The 16 in the medium-sized triangle corresponds to the 12 in the baby triangle. And we're just going to cross multiply. And if you get something where your cross products are the same, don't think you're doing anything wrong. That's going to happen in several of these questions today. So 12 times 12, just give you 144. And then 16 times Y. And we're just going to take 144 divided by 16 to get our Y value, which is going to be 9 there. Okay, anybody having a question? Each one of these is a little different. And if you want to redraw the triangles the second time, if that makes it easier, feel free to do that. I just put one set on each of these questions here, but if you need to, you're free to do that. Okay, now this one, big triangle, I have 2 legs forming the right angle labeled here. Short leg is going to be the 6. The long leg is going to be the 8, and then they've got all the way across there that hypotenuse is Y. Okay, now, all these triangles that we're going to separate here in a second are similar to each other, but I want to ask you a question before I do that. Could you just tell me why in that diagram, just for the big triangle, is that enough information without using proportions and similar figures? Could you figure out why, just from what I redrew in that triangle there? Like, how would I do it? I see people shaking their heads. Remember? Pythagorean theorem, yes. Okay, these are all right triangles. So if you've got 2 of the sides, you can find the third side without doing proportion. Okay, so how would you set up Pythagorean theorem for that one? Perfect. Hypotenuse is by itself. The Y is going to be the hypotenuse there. So I don't even have to use a proportion. All of these are right triangles. If you have 2 sides, you can find the third side by just using the Pythagorean theorem. You don't have to use proportions in all these questions. Now, this is actually going to give you 36 and 64, which will add up to give us 100. Do we know square root of 100? 10. Nice number there. Okay. So Y is just going to be 10. I didn't even have to do anything. Now, the other thing I gotta find is x here. So let's see what we got going on. All right, my medium-sized triangle right here. They don't have the right angle drawn in here, so I'm going to go ahead and do that real quick. And in that, let's see, the only side I have labeled there, I've got the hypotenuse, which is going to be 8. And let's see, we've got the short leg, which is going to be x. Now, the little baby triangle is right here. And again, I've only got 2 sides labeled in that little, okay, now, if you got the little baby triangle, that height that's inside there, the x is going to be the long leg. That height is the long leg if you've got the little bitty triangle. Sometimes it's not super obvious which is the short leg and which is the long leg. So if you have the small triangle, that height is the long leg. If you have the medium, it's the short. And then let's see what else do I have labeled. Hypotenuse there is 6. Okay. You actually have a couple options here, but what I would tell you to do real quick, we found that this side here was 10, just using the Pythagorean theorem. Okay, now, if you put that into the diagram, you could use the big one and the medium one to find x, or you could find the big one and the small one to find x. Either way, it's up to you. What I would maybe just do here, I'll just use the big one and the medium one. So the 10 would correspond to the 8, and then the 6 would correspond to the x. And just put them together. Now, if you did the big and the small, you can do that too. We should get the same answer, doesn't matter. So I'm going to say the hypotenuse in each, so I'm going to say 10 over 8. And then short leg, I've got 6 and x. And then I just cross multiply here real quick. Should get 10x, 8 times 6 is 48. So if you divide that by 10, and it's not a nice number here, we're not taking a square root, so bless you. Not going to do simplest radical form. There's no square root here. So just go ahead and round it. This will just be exactly 4.8. Anybody have a question? Okay, I have one more. Like I was telling you, each one of these is just a little bit different. Okay, so overall, big triangle here. Short leg is going to be y. Long leg is going to be x, and the hypotenuse all the way across there is labeling it for you as being 14. Okay, let me ask you a question real quick. Could you, just based on the diagram, tell me the length of this little segment I just colored in red on my plate? Could you tell me this without, how'd you get 6? Sweet. Okay. Do you guys see that this whole thing is 14? If this much of it's 8, just subtract that. So it's not labeled in the picture, but that's actually an extra dimension I can have there is 6. That's going to go in the little bitty baby triangle. All right, so I'm going to color this real quick. So here's my little bitty baby triangle. And there, the short leg is going to be 6. And let's see, we don't have the long leg labeled. That would be the height there on the inside, but it's not labeled. I do have the hypotenuse, which will be y. Okay. And then I got the medium-sized triangle here. And again, they don't have the right angle, so I'm just going to draw that in real quick. It'd be right here. Now, the hypotenuse is always across from the right angle. So if you are looking at that medium-sized triangle, just like cover that up, the hypotenuse is x, the long leg is 8. You don't know the short leg, that's the missing segment that's in the middle there. But all 3 of these are similar to each other. Okay. Now, let's see. Could anybody, using those 3 triangles, all are similar. I just need 2 to set up a proportion. How could I find x there? I was trying to find x. Maybe what would you set up as your proportion? Perfect. Okay. There you go. These guys correspond to each other. And then grab a different color. These guys correspond to each other. Now, this is going to result in one of those just situation. We'll have a geometric mean here. So something like 14 over x equals x over 8. Now, again, if you set it up different than me, as long as we have the same cross products, you're good. There's different ways to set these up. I'm going to do x times x. That's where I get the x squared. 14 times 8 is 112. And then to solve this, I do have to take a square root. We've had to do that on some of the problems, but not others. Let me think. All right, and I know 112 is not a perfect square. So let me see. All right, it is divisible by 4, so I'm just going to make a factor tree here. I just checked out 4. So it's 4 times 28. Okay, now let me break down the 28 real quick. 28 is 4 and 7, right? Right then and there, I've got a pair of 4s. And then 7 is not going to break down any farther other than 1 and 7. So I would just write that 4 roots of 7. You're just looking for a pair, and then anything that doesn't have a pair, you leave it underneath. Okay. Now, let's see. I'm just going to redraw really quick. You don't redraw this on your paper. This is the big triangle and the baby triangle, just so it's not all garbaged up with my first one. So I just redrew it real quick. Big triangle, baby triangle. All right, now, do you guys see where I've got 14 here? That corresponds to the y. And then I've got y here. That corresponds to the 6. So I have the hypotenuse in each and then the short leg in each. And I could use that to set up my proportion. So I'm going to do 14 over y equals y over 6. And again, you'll get this on some of the questions today. So y times y is going to give you y squared. 14 times 6 is some number 84. All right, and then we do have to take a square root. Okay, 84, let me see. 4 and 21. And let's see, 4 I could break down to 2 and 2, so there's a pair. 21 you could break down to 7 and 3, but neither one of those are going to give you anything else that you can pull out, so no partners or anything like that. And move that back down. So I can take a 2 out in front of that, and I'd have a 21 left underneath. Doesn't break down very much. But simplest radical form, that would be my y there. Is anybody having a question? So what we're going to work on today